and welcome to today's webinar where we're going to take a look at the use of artificial intelligence in food safety systems. I'm Chris Higgins, hosting today's webinar, and we'll be joined by James Flynn in just a couple of minutes. Just a couple of pointers before we get started. Please ensure that you are muted throughout. I do believe that Zoom already has that setting in place, but should there be any reason why you come off mute, please make sure that you try to avoid that. We'll get started. So if we just take a little look at the agenda. So today's agenda, we're looking at around about an hour's time in total for the webinar. We'll try and keep that as close to that time limit as possible. We set out a couple of points here to try and do that. So I'm going to run through an introduction very briefly in a moment. And then I'll hand you over, as I mentioned, to James Flynn. He's our CEO and owner here at Primority, where he will introduce today's session, which is going to be focused around HACCP, VACCP and TACCP. So again, just the use of the AI in systems within the food safety. They're going to be a live demo of the system in use, and then we'll move on to a 10 to 15 minute session. We'll try and reserve at the end here for some Q&A, close us off with call to action. I'll touch on the Q&A in a moment, but I think just to get us started and do a brief introduction, myself, I'm Chris Higgins. I'm the Customer Solutions Manager here at Primority. So my role is to work with businesses to ensure that both new and existing customers to ensure that they're getting the best out of the systems that we offer here at Primority. We are based in Scotland. It's about 40 minutes north of Edinburgh. Enjoying some blue skies here at the moment. But one thing I just wanted to ask, you see at the bottom of your screen here, you've got some tabs, you've got Q&A and a chat function. Q&A obviously is where I want you to post any questions. You can post your questions at any point throughout the webinar if you feel it's relevant at that point. But what I will do is I'll reserve those to the end of the session as to not disrupt the flow by kind of stopping and starting with questions as they come in. But we will try and go back to as many of those as we can, time permitting, of course. Okay, well, without further ado, I'm going to pass you over to James Flynn.
Today, what I want to do is take you through a little bit of an introduction to myself first, and then into what it is we're talking about here today. So my background, I've been involved in food safety, doing HACCP for best part of 30 odd years. I started off as a food safety consultant in the mid-1990s. Originally, I wrote some HACCP software in the year 2000, which is 22 years ago, can you believe it? Since then, I've been doing software development, project management, innovations, all in the food safety and quality space throughout that whole time. The most recent quote-unquote employed job that I had was as business development director for the tech company that runs the Red Tractor Assurance Scheme. So Primority itself was founded in 2016, but I'll talk a bit more about that in a moment, as an active business. So we've been going now just coming up 7 years. We have around 10 people, mostly based in the UK. A few of our staff are in India, and we've got some consultants we work with in the US and Canada as well. One or two of them are on the call here today also. Just a little bit more about our journey. We're really focused on innovation at Primority. As you'll see in a moment, what we're really trying to do is help food businesses with the right tools to do the job. And one of the things that's been constant throughout my career has really been, how do we integrate all of this? And that's what I'm going to really talk about today with HACCP, VACCP and TACCP, because they tend to be done separately, don't they? A couple of key points. We started developing our 3i Verify solution, which you're going to see today, and HACCP, VACCP, TACCP is the newest part of that. We got our first customer in 2016, who happens to be Park Cakes, a very large, well-known retail on-label manufacturer of cakes and bakery products to all the big retailers in the UK. We launched FSVP, which is the US FDA Foreign Supplier Verification Program, using our software in 2017. And we followed on from that with the launch of our Global Import Agent business, which Chris is heavily involved with, which helps companies, especially US importers and foreign-based food manufacturers, make sure their products are compliant for US FDA regulations. 2020 was our first Innovate UK project, which resulted in AI Scan. You're going to see that today, a little bit of that. And that was our first movement into the use of artificial intelligence. And I'll explain about that in a moment. That project finished in November 2020. And then shortly after that, we moved on to another Innovate UK project, which is what you're going to see today, which is all focused on what we call HVT, HACCP, VACCP and TACCP. So we're now in the process of finishing that project off, and we expect to be live with that within the next 1 to 2 months. In fact, we've got customers using it now, And we've actually got paying customers using it right now as well. So probably a little bit ahead of schedule in terms of that, but we still want to do a bit of feedback and getting the word out there. And that's one of the reasons for today, is to try and get some of that feedback and get some input from industry who are not our customers. So just some logos of some of the customers we work with. Weetabix and Iceland are probably two of the best known UK brands that we work with. We do all of the supply chain supplier management for Weetabix. Our solution also does all of the internal and GMP auditing at Iceland, and then they're moving on to other things using our solution as well. Park Cakes, actually, our first customer, they were original users and still to this day actually still using our original HACCP Now software, which is getting really, really old, a bit like myself, but they're about to get relieved with a new all singing, all dancing HACCP, VACCP and TACCP system. So in terms of our focus, what we try and focus on, and this will be a familiar story to many of you, I'm sure, the big problem in the food industry is that you've got lots of different departments in a food company, different responsibilities, different goals. Production's goal is to get product out the door. Quality's work is to make sure it's legal and safe. Technical is to make sure it meets the customer specification. And all of these individual departments tend to use their own information. They tend to use paper and spreadsheets, and the result is you've got a lot of chaos going on in terms of information management. That causes problems, it causes delays, it causes inefficiencies, and it also does cause product recalls and safety issues. So this is what we try and do. We try and bring everyone together into one system from a technical and quality food safety perspective, where everyone is using the same information. A good example of that is that a buyer should not be buying from a supplier who's not approved by the technical and quality department, and they should also be buying from trusted sources that have been risk assessed for vulnerabilities and also for food fraud and so on. So it's quite clear that there's a lot of integration that's really still required in the modern food industry today. To achieve this, we basically take the GFSI benchmark standards like BRCGS or FSSC 22000 or SQF, and we distill that down into the core functions that need to take place and understand how the information moves between those core functions. So for example, supplier and raw material approvals impacts into traceability, quality standards, HACCP food safety, and so on. So just before I get into the actual live demo of what we're building here, I want to quickly discuss risk, because it's my belief that a lot of people do risk assessments, but maybe don't necessarily fully understand what risk is and how we can manage it more effectively. Everyone talks about HACCP being a risk-based food safety management system. TACCP and VACCP are supposed to be the same, but they do get handled differently. ISO 31000:2018's definition of risk is that the effect of uncertainty on business objectives. So that can be quite a general term. That this effect can be both positive or negative, and yet we all think about risk as being negative, and it's certainly treated as being negative in the majority of cases. So the business objectives from a food perspective are going to be safe, legal food, high quality, authentic food, especially from HACCP, VACCP, TACCP perspective. But of course, a business has to be profitable and it has to be able to grow. And therefore, all of this needs to work in a way that's cost effective for any business. The uncertainty introduced by food safety hazards or threats definitely can do serious harm to a business. We only need to look at the horse meat scandal in 2011, melamine from China in 2007, E. coli and romaine lettuce in the US, which is still an ongoing thing, and various other major events that happen. But for every major event that's going on, there are hundreds of thousands of small events that are going on which damage the reputation of food businesses and harm consumers. That's what we're really talking about when we're talking about risk. So a little look at problem that the food industry's got. It's kind of like a moving feast, a buffet of all kinds of tools and data sources and consultancy services out there. And they all tend to be specialized in one thing. They've got a silo mentality, you know. So in the case of FERA, it's all about horizon scanning, agronome data analytics, mainly in the agricultural chain. Discernists are more of a database kind of thing. On top of that, you've got a lot of data sources out there, you know, well known, Food Standards Agency, CFIA, Food Safety Authority of Ireland, RASIF, and so on. And there are others. These are the main ones that we have worked with. Every single one of these will describe things slightly differently. You know, a food recall will be described differently at the Food Standards Agency as it will in Canada or the US or whatever. So there's no common language for a lot of these data sources, and that makes it difficult to reliably get data from these sources and then do something useful with it. This is where AI comes in. The other big problem that the food industry has is that the food industry's managers, so I'm talking about technical managers, quality managers, people involved in making sure the food is safe and legal and of high quality, they have a lack of time. They've got lots of compliance tasks, many of which are based on paper and spreadsheets and so on. And the tools they've got either don't fit their processes or they're not fit for purpose. They're running food safety systems on Excel and Word documents and PDFs, and it's the information scattered all over the business, and getting a clear picture of what's going on is almost impossible. You would never ask an accountant these days to run a business with a pen and paper ledger or just a spreadsheet. They've got Sage, they've got QuickBooks, they've got accounting tools. So we need to be providing these kind of tools to technical and quality managers and ditch the spreadsheets. Good systems start with good information, and we need the right tools to get that information. Turning to artificial intelligence for a moment, I mentioned a short time ago there that all of these different data sources out there, they all describe things in different ways, different formats, and so on. And therefore, having a human go through the thousands and thousands of pieces of information which are available there is a very, very time-consuming and error-prone task. However, because these are internet-based data sources, quite often we can get access through what's called an API to the original data source, and then we can train artificial intelligence to read that information and tell us something useful about it. Why would we want to do that? Because HACCP, VACCP and TACCP, their core principle is to identify threats and hazards which are either known to be occurring or it is reasonable to assume that they could occur. And that's what these data sources do. They give us a real-time glimpse at what is actually going on in terms of what hazards are taking place right now. So the concept that we came up with in our solution is to use these trusted data sources and to use a combination of in-house expertise and artificial intelligence through the HACCP, VACCP and TACCP solution that our customers are creating. So adding that into the trusted data sources should give us a better food safety system because we're getting a more rounded view. It's not just the opinion of one person about what the hazards or risks are and how you're going to control them and so on. There's a concept here that says by adding in all this data together, pulling it together in a usable fashion could give us a better food safety system. And that is our proposition. A lot of people will be familiar with reds and greens that you'll see in your risk matrices. But risk is a lot more than that. And we can use data analytics, we can use other ways to measure risk, etc. So for example, how long ago did something happen? If you keep slipping on ice and falling on your backside every day because it's icy, that risk is always going to be there. But in the summer, you don't quite get that same risk, right? So the circumstances change, and therefore the weighting probability of something happening will change according to seasons. It'll change according to whether there is a risk, whether there's a war in Ukraine, or whether there's global warming going on at the moment, whether there's flooding in Pakistan. All of these things feed into a risk model that are not static. It changes. And so this is what I mean when I say risk modeling is a lot more than just greens or reds that people will do once a year and then it's done. It's a changing situation. So this is the model of the solution that we've actually built. In our original project, our AI scan project, we took all these data sources and we used AI to process that data. And using that, we are able to identify what hazards have happened historically and are happening now. We can also identify which companies are affected by those hazards. and we can identify the categories of food products which are affected by those hazards. We can feed this into a configurable risk model and do things like assess impact and take and record action on that. Taking all of this data that gets built up using this approach, we can then move that into raw material risk assessment, HACCP, VACCP and TACCP. And the way that we've done this is that we have built out a neural network map, which I'm going to show you in just a moment, that then is used to conduct raw material risk assessment, HACCP, VACCP and TACCP. These are all the key areas where the risk part needs to be managed, but it can be difficult when you've got 100 suppliers and 300 materials, all coming from different countries all over the world. So these are some of the important points. I have no intentions of going into everything that's in here, other than to say that you remember that slide when we talked about an integrated food safety quality management system. That's what this is. So in here we handle all supplier raw material approvals, we handle finished products, questionnaires that go to suppliers, digital forms for data capture, audits, etc., corrective action management tasks, documents. But the bits that we are going to look at today, we're going to look at raw material risk assessment, we're going to look at AI scan, and we're going to look at HACCP. But before I do that, I'm going to show you the data behind what we're going to look at today. So this is our back-end AI control panel. What this does is, from all those data sources I showed you earlier on in the slide, it gathers every single day any new information from the likes of HACCP, the FDA. So here you're going to see all of the global food alert. We've got, I think there's 24,000 actual food alerts. These are recalls in this case. So this is from Canada, there's some FDA and whatnot down here. So right now today, 31st of August, here's some stuff that's coming from HACCP here. So there's some salmon issues here. These ones don't look like they've been processed by AI yet. Down here, we've got salmonella and sesame seeds from Nigeria, 3 instances there. And then there's pages and pages of this. The key point is that artificial intelligence is reading this and saying, what is the name of the product? What is the problem? What is the hazard? So we're able then to track what the incidence is of various pathogens or pesticides or whatever it is associated with particular products, etc. So that's the kind of first thing. The second thing then is that as that gets processed, it ends up in our hazard neural map. If the hazard's already there, then that's fine. But what we're looking at here is effectively a kind of a global hazard analysis, which is initially populated from the AI side, but then is augmented by people who are using the system. So we've had qualified food safety consultants, some of whom are on the call today, helped populate some of this and sense check it and validate it earlier on in the year. This is typically what you're going to see in a food safety plan, but we dig into this, it'll make a bit more sense when we look at it like a neural network map. So what we're saying here is acrylamide is a chemical hazard, it's a contaminant, and it applies to these different types of operations like baking, broiler, browner, fryer, etc. And what we can do here is we can either manually add a possible cause or AI can add a possible cause. So here we've got possible cause for that hazard might be product rich in asparagine and reducing sugar, and you can see it might have one or more controls here and so on. And along here there's another possible cause, and you could have dozens of possible causes for a particular hazard which apply to particular operations. And these ones happen to be processed, but it might not be processed. This could be food fraud, it could be intentional adulteration, etc. And that's really the principle of what we're looking at here. If I zoom out a little bit, you'll see how this map runs all the way down through to critical limit monitoring, corrective action, validation, and verification. So you can kind of guess how we're going to be able to use this, because this information then can be almost crowdsourced, and others can then use that information to enhance and update their own HACCP, VACCP and TACCP plans. So that's a couple of key principles. So I'm going to come out of here now and let's go see that in action. Clearly, we're going to start with raw material risk assessments because it's a prerequisite program. So we want to do that first before we go anywhere near a HACCP plan. So I'll just come in here. We're going to look at the raw material risk assessment matrix, if you like, for all of these test products in the system here. So what we're looking at is this is the product name, this is the supplier, and if there's a third-party manufacturer, you'll have their name in here as well. I'm just going to pull up one that's not been assessed yet. But the general idea here is that we want one view across the whole risk spectrum, if you like, for each individual material. So you've got the manufacturer, you've got allergen, chemical, microphysical, process, radiological, intentional adulteration, and of course, food fraud. I'm just going to pull up one that's not been assessed, and we'll run through a couple of points. Typically, from a supplier perspective, you're going to approve them based on the performance and based on other criteria, and you're going to risk assess them on that basis also, because you'll risk assess the material separately. So in the system, we've got a range of questions which are all definable. You can set up your own questions around or criteria around that, along with a scoring system, and you can use that to benchmark the performance or the risk level, if you like, of that supplier. So although there are greens and reds here, this is an alternative way of doing a risk assessment on a supplier based on real information. And again, we've built this up based on experience and looking at how you can benchmark against these things. So in this particular case, I'm just going to approve this one. You can be an assessor, you can be an approver and an assessor. This risk assessment then will feed through against that supplier, and we'll be able to compare that with the performance against another supplier based on that risk scoring. So I'm not going to spend too much more on this other than to say that you would run an approval here. I'm just going to approve all of it. And then once this is approved, it's going to have an expiry date. And because it's in an electronic digital system, once it expires, it's going to prompt you to do a new risk assessment, something which spreadsheets need to be looked at every week to be able to do that. So that's approved, goes into history. You can get a trail of that. Let's come back over to some of the actual food safety areas. So let's look at allergen. So in this case, it's slightly different. It's not about the criteria of the supplier or manufacturer. This one is really about the potential risks that can take place for that particular raw material. So here, what we can see is this particular material risk assessment has a matrix, typical risk matrix that you might be familiar with, this type of thing. We've got other ways of doing this as well, but in this particular case, we've defined our probability down the left and our severity across the top. But more than that, we've then decided that we've got some risk banding. So anything that's 1 to 4 is going to be critical, all the red ones. 5 to 8 is going to be high, and so on and so on. Underneath that, we have the risk significance direction. That tells the system what is significant. So anything that's 12 or less is going to be a significant risk, and therefore we're going to need a control or mitigation in place for that. Underneath here, this is where we start using that neural network map, and all of these hazards here come from that neural AI generated network map. Not just AI, it's hybrid AI and human intelligence as well. We'll pull in a few random hazards there. You can add others in here, and when you add them here, they go into that neural network map, and then we use AI to decide if that should be published for everyone, if everyone wants to use that combination. So it's kind of crowdsourcing, augmenting the data through people's experience and what they're actually seeing in their environment. 3 hazards are in the system. We're going to do a quick risk assessment here using that matrix. And again, just run through this. You might say that that's an inherent hazard. For example, if it's a poultry product, salmonella, or soft cheese, listeria, that can be flagged up later on in the HACCP area, for example, to tell us something. And then in here, again, from the neural network map, we've got these control measures. And again, you can add your own in here. And then we run through, again, we assess and approve that. And that becomes a live risk assessment then, which will be prompted for renewal or review at a certain time based on whatever the circumstances are. Same story again here. We can run through approval processes. It doesn't need to be 2 approvers. It can be just one. You can see in this case, I'm an assessor and I'm also an approver. I think you get the idea. So the concept here is that we're going to run assessments for all of these things all the way along. Allergen, chemical, microphysical, process, radiological, and intentional adulteration are all populated from that neural network map. But food fraud is a bit different. Food fraud tends to be either looking at a supply chain or a category of product or country of origin or whatever. And in here, there's some criteria which are set up again in the admin area of this system. And what we're doing here is we're looking at different areas of risk. So the supply chain, ingredient controls, site and company specific, finished products, consequences, and so on. And it's a similar type of approach whereby we've got some criteria, some scoring. There's a scoring system there as well that helps us benchmark. All of this criteria here and the scoring system is all configurable. So you can come up with a standardized approach to how you're going to manage food fraud risk assessment on raw materials. So you see that there's a score there that fits in with at the top. We would do that for each of these different sections here. And just like before, you would do an assessment and then an approval, and you would get your alerts about anything that might have changed on that, etc. Having taken care of the raw material risk assessment side of things, the supplier risk assessment, the food fraud risk assessment, we turn our attention now to the HACCP side of things. What we want to try and do here is bring it all together. We want to bring together all of these different types of hazards and so on. For the purposes of brevity, I just want to get through the basics of this. Yes, it's called the HACCP plan up here, but the scope of this HACCP plan is actually covering raw material risk, it's covering process, it's covering, let me just open up this chilled storage one. This one, chilled storage, I've got a step name, step number and so on here. And then here, this is the key part. You remember I showed you the neural network map for all these different types of operations. I can select from that map simply by saying, yeah, this is a refrigerated, chilled storage, frozen storage, type of process step. Again, it doesn't need to be a process step. It could be a step in the supply chain. So you can build out your process flow throughout the supply chain and analyze all this stuff. We also are saying it applies to these two products. And because we've got a recipe in the system for these two products, we know what the raw materials are. And therefore, we can pull through raw material risks. If I just move through to the next tab here on hazards, what we now start to see is the system bringing through all the hazards and risks that are applicable to this product and this process step. So here are some examples of hazards that are pulled through from the recipe. They're all just examples. They're not meant to be accurate here. It's all kind of testing stuff in here. So there's all the possible hazards here. I might look at this one and say, yeah, well, that might be an issue for me. So I'm going to add this on to one of my accepted hazards. And again, that makes a link between a raw material risk and what's going on in our HACCP process. Underneath that, we've got process hazard. What I can do is imagine there was fish products here. I might say, well, histamine's a problem. I'm going to add that one in. That's now in the system. Scrombotoxin, for example, and that's one of my accepted hazards. So I'm going to move on in a moment and control that. But while I'm here, I might also want to look at intentional adulteration. What could happen in the chilled storage process step? Could someone come along and mess with the product, contaminate it in some way? Do we have those hazards dealt with and so on? So again, adulteration of ingredients in storage might be one. So I've got both of them there, so it's not adding them again. So I've got those two. Underneath that, we've got food fraud. So it's pulled in meat or fish illegally processed, maybe due to a fraudulent supplier. I think I've got that one already. Corrupt staff or management. I've also got that one there as well. Or it could be misrepresentation through a fraudulent supplier, for example. Can put that one in there also. You'll get the idea that what we're doing here is we're taking a holistic view of all of the kinds of things that could go wrong, not just in a process, but also in the supply chain, and maybe even after our process is finished as well. Counterfeiting, substitution, adulteration, all of these things are things which really should be looked at in the round in order to get a handle on them and control them. So let's move through to the control tab. Again, from that neural network map, we're able to select controls. So histamine, so it's going to be about either intake test or temperature monitoring. So we'll select that one. If the control you want is not there, you can add it and it goes into that neural network map. Let's go down here, intentional adulteration. I'm going to want a visual inspection here, and I'm going to want products getting stored in a secure location. So we'll have those controls. Let's go look at food fraud, misrepresentation. We're going to do frequent testing with ingredients, so we're going to do something else. I'm going to accept that. As we are developing this, we can very easily review things and add new information as new risks come to light and can be suggested by the system, for example. So that's our HACCP. Here's our intentional adulteration. So I've got this one to do, depending on various information. Again, I'm just putting in examples for speed here. We then come through to CCP. So the CCP really is all about the critical control points about the process hazards. And in this case, it's highlighting this is the one I haven't done yet. So I might go here and I might say it's managed by prerequisite program. So in that case, it's not a CCP. The system wants me to look at a prerequisite program. It might be supplier management in that particular case, or If it was a CCP, then maybe what I would do is, I'll just make an example here. If I said that with process step was designed, that would make it a CCP. I don't need to select a PRP because I'm going to select the monitoring and so on, the critical limits, etc., when I get to the next stage here. So just review the others. Intentional adulteration. I can see this one needs a PRP associated with it. So maybe this is staff training or food defense, let's say. You can select that. Again, that can link into documentations, SOPs, and so on. And then under here, we've got supplier approval program for the food fraud hazard. So that's going to be supplier management. And then down here, there might be a food defense PRP required here as well. Unlike a lot of HACCP plans, what this is doing is linking everything together. It's linking through the documentation, the procedures, and it's also linking through to known or reasonably foreseeable hazards that happen in these different areas here. Okay, let's go through the hazard management, see what we've got there. So again, from that neural network map you saw earlier on, there is various critical limits, and if there's not one there, you can add it, or if the one that's there isn't what you need, you can add that. So the responsible person here might be the manager for that monitoring. And then over here, we've got temperature monitoring here, and maybe that's what is this, histamine levels at each delivery perhaps, and then who's going to be responsible for that. And again, you can add your own data into this. So we'll just run through the rest of this. This is intentional adulteration. There might be some testing we want to do. So what the testing limits are, whatever they are for that. Line checkup procedures, each production run, and so on and so on. I think you'll get the idea here. All of it's been populated initially through AI and then augmenting that data from the use of people who are actually controlling and managing this type of information. So a bit of crowdsourcing involved in all of that as well. Same idea down here. I'm not going to do all of these, but again, you can get the general idea. Once you've populated that neural map, it doesn't need to be approved for you to use it. You can put something in there that's relevant only to you, but AI might not approve it. That just means that only you can see that particular piece of data. If it's approved for general use, then that information can then be used by anyone who's got access to the system. So it's kind of like a self-learning, crowdsourced type of approach. Okay, so generally speaking, we would box off the management. There's quite a bit to do there, so I'm just going to move on to validation and verification. In this case, the raw material risk assessment's kind of stopped here because we already risk assessed them. So we're now focused really on processes, intentional adulteration and food fraud. And validation, again, can be driven and updated into that neural network map. Again, we can all benefit from that. Same idea for intentional adulteration down here, and also for food fraud and so on there as well. Validation, making sure that the control measure, critical limit, and so on will work is what that's all about. Verification, all about proof that it is actually working. So what checks are you going to do to make sure that your controls are effective and keeping things safe and so on. I'm conscious of time and I've thrown quite a lot of information at you. So what I'm going to do is I'm just going to come out of here and back to the process flow diagram. This is all drag and drop, by the way. You can really quickly build out your process flows, join everything up and color code things and all of that sort of stuff. And if you've got these AI-driven HACCP, VACCP, TACCP tools at the back of it, this could be a supply chain map, or it could be an individual process flow, or it could be some sort of other operational supply chain issue that you want to do here. It's not just about process steps. Okay, so I think I'm going to stop there. I've probably spoken too much, and I'll hand you back to Chris to run any Q&A, and then we'll talk a little bit about our offer to you guys and see if you're interested in working with us, helping us out, evaluating this and providing us with some feedback, etc. Okay, over to you, Chris.
Thanks, James. Yeah, a really, really nice overview and some really good questions coming in. So thanks everybody that's been interacting in the chat. I appreciate there was one or two very slight issues just with the selecting of the right screen. So hopefully got everybody through that as we were going through there, and you didn't miss too much. But if you did miss anything, a recording will be available after the webinar as well. So we can always organise getting that out to you should that be relevant. But let's jump to a few questions. We've got 5 so far. As we're running through these guys, we've probably got about 5-10 minutes for this, so we could probably get through a couple more. So if there is anything else that you think of, just as we start to run through these, then please do interact in the Q&A part down the bottom. There's a little tab at the bottom of your screen. We'll get through as many of these as we can. So we're talking about food fraud just as a whole. It's a huge area. One estimate value is the size of the Ukrainian economy, but given the complexity of the global supply chain, James, how does the software actually monitor emerging risks and any incidents that are happening?
Yeah, that's a great question. So behind all of this, I did mention that you're only really seeing a small part of the system. In our AI scan solution here, we've got these three tools here, and we are adding more. We've got another tool, which I'll speak about in a minute, which is coming in the next 4 to 6 weeks or so. Three things. First one is that our AI scan solution takes all of that data that it's gathering, and it will feed it and join it up with your suppliers in the system. So this is supplier based, right? So this is telling us about, for example, Garden Fresh Foods in the US here. There's UK stuff here as well. It's from all over the world. Whatever supplier you add in here, it will join it up to that global food alert data. So let's look at this one. These are all numbers that come out as a result of the risk scoring algorithm that you can set up in the system. But if we just click into that, we can see this particular supplier and the kind of issues that they may be having. If you're based in the UK, why should you care about the FDA? Well, you should care because the company you're buying from, whether they're in India, the UK, or wherever, if they're supplying to the US and the US is doing at the border monitoring or inspections or testing or whatever, then they're very good at publishing that kind of information. So we can get intelligence from that. So anyway, these guys are based somewhere in Wisconsin. You can view them on Google, FDA, Open Corporates, which is kind of like a Wikipedia for Companies House. You can view the certification, which in this case I can see has expired. Everything you click on will take you through to the original place where we got that data from. That record expired there, although the last audit rating was excellent. That's the one point. The other point is that you can then, down here, this will pick up things like allergen alerts. So these guys had some undeclared milk in there. They had a whole bunch of FDA citations. Again, that'll take you straight through to the source of that, whatnot. So you've got kind of supplier stuff. Coming back to the topic of the actual raw materials and so on, so let's go jumping back to the AI scan menu here. We've got two tools here. One of them is, you might remember what I showed you, the global food alert. There are the live alerts in your system. So there's the humpback salmon one we looked at a moment ago. What you can do is you can, and this is not just looking at RACCP, it's looking at Canada, US, UK, whatever. You can set up an alert profile in here to say, for example, well, who remembers the soy lecithin issue in May or April actually, but no one really knew about it until May. You can add in lecithin or undeclared peanut or whatever it is, so you can pick up any alerts that are coming in on that from all of these data sources. And we can add in more data sources. The other parts though are about anomaly detection. So anomaly detection is using a proprietary algorithm that we've developed, which will go and look at all of that food alert data, and it will carry out what's called an anomaly score on each of the data points that come in. Now this is historic, so this is back in 2019, which kind of shows a bit with how this validates. So down here, these red ones are the kind of food alerts that are coming in, and it's the count of food alert really. What this is the anomaly score. So our algorithm is looking for unusual patterns. So it's looking for things that are new, that are not seen before or not seen for a while. It's looking for an unusual frequency of occurrence, and it's looking for other things. So it is really quite a close definition to what you would call horizon scanning, because that's what horizon scanning is for. Zooming into this part of the chart here, what we can do is go look at the data associated with that, and this will bring up all of the issues. And if I just sort these quickly by anomaly score, you see the ones with the high anomaly score are the ones resulting in the uptick in that chart. And all of these are, you can see quite clearly, CFIA is Canada, Canadian Food Inspection Agency. So what we're looking at here is a whole bunch of really unusual frequency of E. coli alerts regarding a particular incident. And again, we can click through on that and go see what the story is with that. It was a big beef E. coli alert in 2019. So that's another way. Final way is in our dashboard, where you can get that data presented in the way that you need it presented. So for example, that data is coming from AI scan, and these are just example reports. It's looking at all of the data. So if I just focus in on 2022 here, you can see that the share of events in terms of actions, regulatory refusals, etc., and the different types of hazards and whatnot here, and get the trends on those. You can also look at anomalies by hazard, so you can drill into different hazard types and whatnot. Again, this is just an example, but it's based on real data, and you can see right there, there's that anomaly in 2019 we just looked at a moment ago, which sticks out like a sore thumb. If this is the normal background and you see something like this sticking out, you would want to be investigating it if that's in your supply chain. Hopefully that gives you an idea of some of the different aspects that are available here.
Perfect. Thanks, James. Okay, so there's a few more questions here. We'll try and get through another handful of these. I'll just come to you, Victoria, first, because I know you've mentioned two, and then I'll come to you, Sebastian. You've sent two in as well. Victoria, absolutely, the webinar will be available as a recording after the session. Also, the presentation that James is running through before you went into the demo will be available, and within that deck there is actually screenshots from the system itself. So whichever you prefer, both are available. We can get both of them out to you, no problem at all. And Victoria also had a question, James. It talks about the allergen management. Can you break down by individual major serious allergens?
Yes, in fact, in our supplier approval system, what we do is we gather the allergen risk assessment information directly from the supplier. And what we're planning on doing with that is we're actually going to change the way we're doing the allergen risk assessment. And we're not going to do it via a matrix against each individual material. We're going to do it based on whether the supplier has told us if it's handled on site, if it's handled on the same production line, what the quality is of their documentation that they've provided. So this is a kind of questionnaire that gets sent out to suppliers, and in the material specification one, and again this is just an example, everything's digitally designed in the system. This is the allergen assessment in this section here, and in that questionnaire it's gone to that supplier for this material. We're asking them, is it contained in the raw material? What's the risk of cross contact? Is it handled on site, same production line? You might also ask, do you have a dedicated area? Is it mentioned on the label? These are the real factors that feed into the risk for that material from this site. Well, a site doesn't handle a major allergen on site, but the other supplier does. So the risk is clearly different in those cases. We are reviewing how we're doing the allergen raw material risk assessment at the moment on that basis. That's what we're going to change it to, is something that automates from that. Hopefully that answers your question, Victoria.
Perfect. Thanks very much. Yeah, so a couple of questions then from Sebastian, both I think on a similar footing. You probably get them both in the same point here. Is will the AI give a warning or risk level dependent on the country of origin? And then additionally, is the platform only geared towards importers? So there's a couple of questions in there.
The platform is very much geared towards manufacturers and processors of food products, because it's them that really need to manage that risk. In the US, importers need to have an FSVP in place, but it doesn't need to be as detailed as this. In the US, it's really all about making sure that the US importer has identified all known and reasonably foreseeable hazards according to FDA. You can interpret that in a number of different ways. Could be that the known and reasonably foreseeable hazards is based on data that's out there, which some people do that. In other ways, a high risk material, you may want to develop your own food safety management plan or preventive controls plan to be able to deal with that. System's flexible. We can set the system to be more complex depending on the information requirements, or more simple according to whatever the need is.
Thanks, James. There's a couple of final questions here. I think we can squeeze these in and then just get to the final point. Timia Harris, I hope I'm pronouncing that correct. As a global company, can we have multiple risks against one material based on where the material comes from? I think the short answer to that be yes, James.
Yeah, absolutely. So, hi, Timia. We met at London at the Proactive Food Safety Conference, I believe. But yeah, coming back to drill into that, because I know that is important to Timia. The point is that using the questionnaire part of the system, we are gathering information about the raw material and where it comes from, right? So, for example, in this particular case, we might have pasta that's made up of wheat and salt. The supplier's filled all this stuff in, and it's coming from the United Kingdom, but originally from Albania, for example. All of this information is related to that particular raw material, and then we've done a raw material risk assessment against that particular raw material. We can also look up, for example, things like even climate change, weather patterns, the corruption index of that country, and we can feed that into what we would call a food fraud index. Once we've got the data up front, we can then begin to answer all of those kinds of questions. Where is the highest probability of a particular risk? Is it higher in Afghanistan or Ukraine versus Ireland or Canada, for example? Using that data, we can do that. Hope that answers your question.
Perfect. And a very final question. I appreciate that's the hour up, guys. So just please give us one or two final moments here. Just want to show you a final slide that has an introductory offer for you as well. But very final question, James, very quickly from Helen. Did you develop your own software for building the process flow diagram?
Hi, Helen. Yes, we developed all of the system from start to finish. We do use components for various things. Assume that you're talking about the actual flow diagram part. That is the bit with the boxes and the lines and arrows on it. that particular component is a component we bought in and then customized to our own needs. Everything you're seeing today, we built all of it in-house through our very talented team of developers. Just want to give them a bit of credit because they work incredibly hard to listen to my crazy demands about making the system do what we need to make it do.
I just wanted to show you one very final slide here. It's a kind of call to action, if you will, and ultimately it boils down to a free evaluation of the system. So what we're saying that although we do have some customers currently evaluating that for us, it will be available over the next couple of weeks. There's some finishing touches, as we pointed out as well. So what we're offering here is an opportunity to try the system out free of charge, provide us with feedback based on your findings and the use of the system as you go through that evaluation. And then on top of that, if you do go through an evaluation, then you will be eligible, if you will, for a 30% discount if you later decide to sign up to the module before the end of 2022. So what we're asking here is, if you are interested in that or you want to know more, then please do contact us on connect@primority.com. I put that in the chat as well a little earlier on for everybody, so hopefully you've got that. We'll be in touch anyway at the back of the webinar, but if you are wanting to speak specifically about the evaluation, then please do contact us using the subject line HACCP VACCP TACCP if you can. Again, really appreciate everybody joining, and again, the webinar itself as a recording and also this deck will be available after the call. We'll be in touch to let you know when that's available and how you can get that. Or if you do have anything specific for James, you can see his contact details there on screen. We'll leave those on screen for a couple of minutes if you do wish to get that. But that does bring us to the end of today's webinar. So again, just wish to extend my gratitude to everybody for joining today and wish you all the best. Enjoy the rest of your week. Thanks, everybody.
Yeah, thanks all. Thank you. Bye-bye.